Okay, in this video we're talking about balancing equations. Now there's a couple things that you guys need to know in order to be able to balance an equation. First we need to know what some things are called. So if we look at an example of an equation like this one, the things that we are putting into the chemical reaction, the things that are reacting with each other, those are called the reactants. In this case we have hydrogen is going to react with oxygen. On the other side, we can kind of think of this arrow actually means yields. So you can kind of think of the arrow as an equal sign. So we have an equation, we have two sides separated by the equal sign here in the middle. So these two things, the reactants, are going to react together and produce something else. What it produces on the other side, we call those the products. So in this case we have hydrogen and oxygen. Those are going to react and produce two H2Os, or two water molecules in that case. Some of the numbers, the names for the numbers, if I am talking about a coefficient, you should know that I am talking about the big number out in front here. So like this 2 would be a coefficient, and this 2 would be a coefficient as well. The subscripts, those are the little numbers down behind each of the elements. If you see a subscript that is telling you that there, like for example this one is a 2, that means that there are 2 hydrogens in that case. This coefficient out in front tells us that we have 2 of the whole molecule here. So we have 2 H2Os, 2 H2Os there. So if we have 2 H2Os, then that means that we have 4 hydrogen and 2 oxygen. We'll get into that in a little bit. So this page you can kind of write down the definitions of different things, what the reactants are, products, what a chemical reaction is, and what a chemical equation is. So you can pause it in the video and write those things down. When we're balancing chemical equations, we have to think about the conservation of energy, or the law of conservation of energy, and then we also have the law of conservation of mass. Basically, with the law of conservation of energy, you guys have heard these things before, that energy cannot be created nor destroyed. It can only be transferred into a different type of energy. Conservation of mass, same thing. Mass cannot be created nor destroyed, only transferred into a different type of mass. So basically all that is saying is that all the energy and all the mass has to be accounted for. If we look at an example here of a chemical equation, on this side these are the reactants, what's going into, so these are the reactants, what's going into our chemical reaction. These are reacting together to produce what's on the other side. So if we look at these, if we look at P here, which is phosphorus, we have 4 phosphorus reacting with 2 oxygen on this side. So we have 2 oxygen and 4 phosphorus. On this side, right now, this is an example of an unbalanced equation. We only have 2 phosphorus and 3 oxygen over here. So basically this is an unbalanced equation. If we think about the conservation of mass, we have 4 phosphorus and 2 phosphorus over here. What happened to the other 2 phosphorus? Keep in mind, with the law of conservation of mass tells us that they can't just vanish. They can't just disappear. So you have to account for everything going in has to be equal to what is coming out of the other side. That's what these two things are basically telling us. Okay, so keep that in mind whenever we are balancing equations. All reactions, so when we deal with chemical reactions, all reactions release or absorb energy. So they're doing one of those two. If they are going to release energy, we call that an exergonic reaction. If that energy is in the form of heat, then we call it an exothermic reaction. So we're giving off thermal energy. We're giving off heat in that case. So just like a fire, combustion, that's going to be an example of an exothermic reaction, also an exergonic reaction. So those work for both of those. This one is giving off an energy, so it might not be giving off heat, so it's not an exothermic reaction, but it is an exergonic reaction because it's giving off energy in the form of light in that case. If it is absorbing energy, we call that endergonic reaction. And then if it is absorbing heat, that would be an endothermic. It's going into the reaction. Something is absorbing that energy to be able to use it in that chemical reaction. Okay, so let's do some practice problems of how to balance equations in this case. And there's no magical way of balancing equations. You just have to kind of mess around with it until you see what works. One thing we can do is we can divide, put a line kind of in the middle if that helps you, or you can just draw it down here if you want to, and kind of keep track of how many are on each side. So these are our reactants on this side. This side we have our products, so they have to be equal. That means all our hydrogens, however many hydrogens we have on this side, we have to have on the product side as well. However many oxygens we have to have that many oxygens. Okay, so in this case, we just kind of have to mess around with the numbers. Here we have 2 hydrogens, on this side we have 2 hydrogens, so those are balanced right now. So we can kind of keep track of that. So H equals 2 on this side, H equals 2 on this side. Oxygen on this side equals 2, oxygen on this side equals only 1. So we have no coefficients. One thing you need to know when you're balancing equations, you cannot change the subscripts. So these little numbers after the elements, if you change these, you're changing what the molecule is. So if you change that number, it's no longer a water molecule on this side. So you can only change the coefficients or the big numbers out in front. So these numbers are what we're going to change. Okay, so if we look at these, so oxygen equals 1 in this case. So oxygen and oxygen are not balanced now. We have to balance those out. And sometimes you're going to change the hydrogens as well in the process. So if we want to balance these out, we could put a 2 in front of this one, giving us now 2 oxygens. But that also changes our hydrogen. Now we have 4 hydrogen on this side. So now our oxygen and oxygens are balanced. Hydrogen is not balanced anymore. So we can go back over here. If we put a 2 in front of this, now we have 4 hydrogens again. So now we have 4 hydrogen, 2 oxygen, 2 oxygen. Now that's a balanced equation. You've accounted for everything going into it. We have 4 hydrogens, and then on the other side we have 4 hydrogens as well. We have 2 oxygens going into that reaction, and we've accounted for it on the other side. Another example, we have sodium and chlorine to make salt in this case, so sodium chloride, and we want to balance that equation. So again, start out, let's just look at one element at a time. Na is going to equal 1 on this side. Na on this side equals 1. Cl equals 2. On this side we have Cl equals 1. So these NAs are balanced right now, but the CLs are not, so we need to balance those. So we can't go down in coefficients either, so we can't take one away. Cl, we need to add another 2 out in front. We can only change the coefficients out in front again, and so that makes our CLs balanced. But what does that do to our Na? That changes that one to 2. So now our NAs are not balanced, so we need to go back and balance those again. That gives us 2 Na. So now we have 2 NAs on both sides, 2 chlorine on both sides. We have a balanced equation now. So not too hard, you just gotta kind of keep track of them and make sure that you're only changing the coefficients, you're not changing the subscripts. And another thing, we don't, even though in the simulation, the only thing I didn't like about that simulation is that you had to put a 1 in front of these. So again, if it's just a 1, we don't actually have to write in the 1. It's just assume that Cl represents 1 Cl in that case. So don't write 1s in front of those. Alright, so these are a couple examples. I want you guys to do both of those. In your answer on the summary, I want you guys to just write out the numbers for the coefficients that you're going to put in there. So if you have a 2 right here, and then we had a 3 right here, and a 2 right here, then you would write 2, 3, 2 in order for your answer. So if we had a 2 right here, 3, and then a 2, in the box I just want you guys to write 2, 3, 2. You can put commas in between them. So that should be your answer whenever you're filling those in on the video. So do these 2 practice problems. This is not correct. I was just making up numbers. Solve these problems, and I'll see you guys in class.